Thank you. So welcome. It's a real pleasure to host you today. So my name is Anana Michison. I'm a health technology assessment statistician and also a member of the French Society of Statistics. So particularly the subgroup on biopharmacy and health. So the group includes members from various sectors in health and also pharmaceutical industry. So we have, of course, those pharma companies, but also members from public research or academia, and membership is open to all. So our goal is to facilitate discussion and foster collaboration between statisticians and users of statistics between, in the sector of healthcare, and to support us with this mission. So we organize workshops, different training session, conference, but also working group. And therefore, we promote the profession of statistician and serve as a bridge between French but also European professionals. So thanks again for joining us today. We're excited to give you a preview of one of the short courses that will take place this October in France. So the term is Advancing Drug Development Through Innovative Design and Efficient Data Use. So we have 3 different sessions and 2 short courses. So the objective of the webinar is to teach the second short course and therefore provide practical tips while exploring software engineering practice that can help and support you to enhance your R code. So thank you for being there. And before handing over to Jack and Daniel, who will anime this session, I will hand over to Caroline, so my fellow from SFTS, who organized this webinar with me. Caroline, the floor is yours.
Hello, everyone. Thank you for joining the webinar. I hope you enjoy it. I am an associate director at Merck, and I'm happy to work with Hanan to give you this opportunity today. And now I leave the floor to Daniel and Jack.
Thank you, Caroline, and thank you, Hanan. So welcome to this little preview session of the Good Software Engineering Practice for R Packages course. So let's see. So the usual disclaimer, and we can move on. So today, what are we going to do today? So as mentioned, give you a preview of this lovely short course that will take place in Paris, France. But no worries if you can't make it to the conference, because we will share all of the materials of this upcoming short course online. And plus, you will learn some awesome things right here today. So where are we from? What's the working group we're coming from? It's called Open Statsware, so Open Statistical Software in short. And you can find out more at our website, openstatsware.org. So we are almost 3 years old, so still like in toddler age, but already a few years here. So, and we are associated both with the American Society, so the American Statistical Association Biopharmaceutical Section, and also the European Federation of Statisticians in the Pharmaceutical Industry. And we are more than 60 statisticians at the moment from more than 30 organizations. And what's the goal? We want to engineer R packages and other software packages together, and also want to spread the best practices how to engineer those packages. And the second objective, of course, that's kind of the topic of today. So a little bit about myself. From the background, I'm a statistician, so I did my PhD in Zurich, Switzerland, working on Bayesian model selection more than 10 years ago now, and then started my career at Roche. Was there 5 years in early development, then had a stint at Google for 2 years, working on advertising, completely different stuff, but fell in love more with the statistical engineering side of things, and that's why I came back to Roche then to lead and build up the statistical software engineering team there at Roche Biostatistics. Then middle of last year, another exciting chapter, I co-founded RCONIS, which is Research Consulting and Innovative Solutions, company with 3 other people. And yeah, it's already been a year now, so it's also kind of another birthday there, which is very nice. I've written multiple R packages, so worked with R for more than 20 years now, and also wrote a book that might be interesting for you if you're into statistics. And I'm also one of the co-chairs of OpenStatsWare. So happy to connect with you on LinkedIn or GitHub. Over to you, Jack.
Thanks, Daniel. Yeah, so hi everyone. So I'm Jack Talboys. So I'm not quite as qualified as Daniel. I've got a bachelor's in statistics from the University of Bath, but since then I've worked mainly as a data scientist. So I worked for Mango Solutions in Ascent, which is a data consultancy, for about 5 years. So that was working across a range of industries, so finance, insurance, pharmaceuticals as well, kind of generally building tools in our Shiny applications, our packages, a bit of work in Python as well. And then last April, I joined Novartis as a software developer, part of the open source enablement team. So day to day now, that looks more like kind of helping study teams. So whether that's kind of direct support, reviewing their code, kind of holding their hand while they're trying to implement, new methodologies within R, or whether it's kind of building tools to try and help them work more efficiently. But yeah, really enjoyed my work, and yeah, glad to be part of this webinar and then the course in October as well. Do you want to carry on sharing, Daniel? I think there's just a few slides for me to go to. Okay. So what do we mean by good software engineering practice for R, which is what that slightly long acronym at the top there means. So I'm sure you're all familiar with kind of good XYZ practice. So, being from pharmaceutical and technological backgrounds, there's, good clinical practice, good development practice. So I think a lot of people come to R from more statistical backgrounds. So we really want to kind of try and spread knowledge and information around how to kind of produce better code within R. So, good software engineering practice is definitely a thing, but we want to spread that to R and other open source technologies. So if we do that, we can definitely improve the quality and longevity of our R code and packages. If we improve the quality, then it's easier for us to maintain. It's easier for other people to contribute to in the future. And then another important thing to say is that there's not a kind of a universal gold standard to these best practices. We're going to share some perspectives both today and in the course in October, but they're based off opinions. They're based off our experience of working with open source software up to this point. There's different ways of doing things, and there's definitely lots of different correct ways of doing things, but hopefully you can pick something up from these sessions. Yeah, if you want to go to the next slide, Daniel. So why should we care about this? So as I mentioned, R is an incredibly successful statistical programming language, but lots of people coming to it aren't from a traditional software engineering background. So that's why we want to kind of try and help merge the two, which I think is why this conference is a great place for us to be delivering this short course, because you guys know a lot about statistics and all the different methodologies that are implemented in R, and we want to help you to be able to kind of both write your own code that utilizes what's available, but also to be able to kind of create new things and share those with other people. So R has a really kind of powerful ecosystem. It's essentially fueled by R packages. So what we mean by packages, it's essentially kind of a collection of files, mainly R scripts that contain functions that can kind of be packaged up and shared across users, whether you kind of email it to colleagues or you kind of do it more formally and upload it to a shared repository where everyone can install your package from. So a lot of the mature users in R will have been making these packages for years. There's a website called CRAN, which is basically a massive repository for all of these packages. So if you've ever used R up to this point and run the install.packages command, it's picking this package up from CRAN, making it available in your R session so that you have kind of a whole host of new code available for you to use. Another thing that's important is kind of as the R ecosystem continues to grow, more packages are made available to you. It's good for yourselves to understand what good practices in terms of software engineering look like, because it allows you to assess the quality of packages. As there's more and more available, we want to know that any code that we're bringing into our R session that we're using to develop with is good quality, that we can trust it. So having a good understanding yourself of software engineering practices is a good idea. And of course, R isn't the only open source language. There's Python, there's Julia, and a lot of the concepts that we're going to talk about both today and in the short course, much more widely applicable. Obviously, all of our examples, and we'll run through some live demos, and the short course in October we'll let you guys have a go yourself. But that will all be in R. But yeah, definitely the principles can be more widely applied. So again, here's what you'll learn. So the more kind of hands-on exercises where you'll be in the room with myself and Daniel. You'll have more of an opportunity to ask questions as you go through the exercises, such as creating your own R package. We'll do in October, but today we're kind of hoping to give you a flavour. So we want you to understand what an R package looks like, why it's beneficial in terms of implementing good practices, what workflows you can put in place to make sure that the package development goes as well as possible, as well as kind of some fundamentals of quality control. And then finally, one of the most important things is, once you've used all of the skills that you've picked up as part of this to make your own package, how can you share that with other people? Okay, I think back over to you, Daniel.
Thanks, Jack. Yeah, great. So let's start with the first kind of topic. And the one kind of, let's say, preview slide and preview topic we want to grab here was just a very high-level overview. How could this work, right? How could you go from a simple R script that you have developed for, analyzing one particular data set or fit one particular model to one data set? How can you go from that to a package, to an R package in principle, right? And there's a few different steps that are typical, right? So the first step that we will show in a little demo now is actually the crucial step, is that you go from the script towards writing functions. And those functions, basically, each of them kind of should encapsulate one particular action or one particular behavior that's kind of important and that might be repeated on other projects. One other detail is that in the package, of course, you want to avoid any kind of global state of variables. So for example, you don't want to load packages with library, but we will see how we do that in the package. And you also, for example, don't set options, and you don't save things to the workspace. All of these global things you avoid as much as possible. So they are very rarely done in packages. We'll talk about this also a little bit more, but it's also important to think about the coding style. So basically in the package, things should look relatively tidy and nice, and kind of consistent, so that it becomes easier in the future for you to come back to this code and change things. Similarly, also you need to document your functions. So we will also have a very quick look at that. We will later show a little bit about test cases, so how you can add tests to your package in principle. Then later, of course, you can also think about refactoring, optimizing your code in your package, because when you have those tests in place, then you have fixed basically the behavior of the function. The function should always fulfill the test case successfully, and then it's the time, for example, to think about making things faster, making things even nicer in terms of the code. That's all the refactoring optimization. Versioning your code and sharing this as an R package, it kind of goes hand in hand, because each R package has a version. And that makes it very easy to version your whole code base. And then, of course, as Jack mentioned, sharing the package then, for example, on cron or on GitHub is then the kind of final step, once you have a first version of the package that is worth sharing. So I'm just gonna show a little bit about this, especially the first point. What do we mean by this encapsulation of behavior, writing those functions? Let me just go out of this view for a second. And also just to give you a little bit of flavor, how hands-on the course will be in Paris in October, right? So there, of course, we will have exercises for you as well, but we thought we'd give you a little bit of a demo session here as well. So let's say we have this very dummy script here that was actually generated with an LLM, but doesn't really matter. So just a simple script. So we have a little data set here in the script, and what we're going to do is we want to basically order the data set, right? So we have just sampled here some values for value and for category, and so it's not really ordered at all. We just have the ID ordering here. And of course, here in the script, we can just do like this. We write our comments. We basically define some new global variables. Now we have something ordered, and we can print it and so on. Or we can also have the other situation that we maybe want to have multiple columns and even some different order, and then print things again. So it's very, very, very simple thing here, right? And of course, the topic you can see here is about ordering the data set, right? So how would I go about if I want to encapsulate this in functions? So I prepared this a little bit before so that I don't need to take too much time. But basically, this is kind of one of the results that I got to. And of course, there are many different solutions and ways to do this. But important thing is already to think about the name of the function, right? So here, always try to make it like a verb, something that's action, an action that's taking place. So here, for example, order data. You see, I'm using here a snake case for the function name. I'm also using a snake case inside the function for those variables. So that's already part of the kind of consistent style idea. I'm also using his snake case for this argument. Okay, and I take here two arguments. The one is a data frame. The one is this order by. And one very important thing is those assertions for those arguments. Okay, so because R is not a typed language, so we can basically have any kind of things being inserted here by the user in principle. But we want to make sure that we are sure that this df is a data frame, and we want to make sure that this order by is a character vector of minimum length 1 before we continue. And otherwise, it will throw an error to your user. So the checkmate package is here very, very helpful for these kind of things. And you see also here how we actually call these other packages, right? So I'm not saying here library checkmate, but I'm saying, so in the script, I just say library deployer, for example. But here, I wanna basically directly use those functions from the namespace, right? So I'm using here the third data frame function from the checkmate namespace. Okay. So this is how we want to use other packages within our own function in our package. Then the other thing that you might notice as well, there's actually no deployer calls anymore here. Okay, and this is something that is not, there's no strict rule about this. I personally have a rule. I try to avoid to use tidyverse and deployer within functions as much as I can. Most of the things you can do with base R. In particular, you can use this ordering of data frames is very standard in base R. So it's very easy. But that's more like a choice, more like a subjective choice. What else we can see here if we compare this with the script? Yeah, I mean, I left here the kind of printing with this cut here. But of course, normally in functions, you don't really print so many things. I also actually don't have too many comments anymore. Before we had a lot of comments, which is also typical in scripts. Usually in functions, you try to be so clear with your code, you actually don't need those comments anymore. Okay. And that comes through clear variable names. So here we say data frame order. So what it is, it's the order called on the data frame. So it's really the correct order. Then we have the ordered data frame. That's when the order is applied to the data frame, right? So it's very clear. And then the last value here without an explicit return. That's also good practice. Just the last value is what is returned to the user, right? So that's just the first step here. And then of course I would have some code to try this out. And I can see that this kind of works here correctly, right? So this is just to give you a little bit about a first idea of this. Okay, over to you, Jack.
Thanks, Daniel. I can share my screen as well. So now we're going to look more specifically at kind of taking that and converting it into an R package. As we mentioned before, you know, an R package is a really good way to develop your R code because it makes it much easier to share at the end. It helps us to control the environment much better. We can think about things like testing and documentation. So an R package is an R package because it follows essentially a standard file structure. So it contains kind of set specific files. So the description file is the first one of these, which essentially contains all of the metadata for a given package. So the title of the package or the name, a description of the package, it will contain the version number, it will contain information about the authors. So if you ever have a problem or find a bug within a package, you'll have an email address that you can contact to try and get help. It can also link to URLs or GitHub repos where packages might be stored, where you can also get help. It will also contain information about dependencies. So what other packages does that package use? The namespace is something that we don't have to worry about too much. This is kind of handled for us automatically, but it essentially defines the functions that are available from this package. So, we write a function, we want to export it, make it available whenever this package is libraried in an R session. The namespace tells the R session what functions to make available. We've got the R directory. So as we say, this is the meat of the package. We're developing an R package. All of the hard work is going to be done by R code in our scripts, and this R folder is naturally where we store all of that. And then the man folder is, again, one that we don't have to worry about too much. It's where all of the documentation around the package is stored. So there's lots of packages within R now that will help us build the documentation from comments that we can leave within the R code, rather than having to kind of manually build markdown documentation ourselves, which is great. And then the tests directory is kind of fairly self-explanatory. It's going to be full of scripts, R scripts that use the test that package. I'll show you a little bit what those tests look like, but yeah. There's also some other optional directories. So data is, again, fairly self-explanatory. If you want to ship any data with your package, so say there's some examples for the functions that you've written that rely on a certain data set, or you're implementing a specific method which requires a certain data type, then these can be included in this data folder. Similarly with vignettes. So vignettes are kind of generally kind of markdown written user guides that are designed to help the user get a better understanding of the package and how they should use it to do what they need to do. And then the last one that we mentioned here is this inst folder, which is a bit more of a kind of a catch-all for anything that doesn't fit inside the others. So for example, in kind of a team I'm working in at the moment, we're kind of starting up a new package, and we just got some R scripts in our inst folder, which just kind of give a general idea of the workflow we're expecting to use with this package as it progresses. And it's useful to have it in there because then it's source controlled and we can kind of see how the workflow changes as we make changes to the functions. But yeah, the inst folder is very flexible. I don't know if we talked about Shiny apps yet, but if you build an R package which is a Shiny application, which is essentially a web application, you can include things like CSS code or JavaScript. So yeah, there's lots of flexibility around the kind of slightly rigid at first seeming R package structure. And then once you've kind of built your package and it has everything that you need it to have, we can build it into a single file, so a tarball, a .tar.gz, and then this can be sent to CRAN for submission. You can even more simply just email it to your colleagues who can install it into their session. So yeah, there's tons of ways that you can share this to whoever else might need the code that you've developed. So this might sound like quite a lot in terms of like the structure that's needed, but luckily, like I say, there's some R packages that help us to take away a lot of the work on our part, and use this is one of those really good ones. So it really simply just offers a a command called, or a function called create package, and then all we have to do is give it the path to the package. So I'm going to go into my RStudio session now. So I've already run the command just because I wanted to save the time of having to kind of switch to a new project in RStudio, which can take a little bit of time. But hopefully you can see that all I've done is use this create package command, and then it's given me like a nice rundown of all the things that it's done. So it's created a new directory, set up a new project, and then it's created those. So we talked about the R folder, the description file. It's also shown me what it's added to the description file. And you can see in my file system on the right-hand side, it's created this SnB example folder for me, which is just essentially the folder which contains everything I need for this to be an R package. So I've got my other tab, which is my project inside of that folder. So here we can see the kind of bare bones, as basic as possible, R package. So since running that use this create package command, I haven't done anything else to this directory. I haven't added any files. I've not touched it at all. So you can see on the right hand side we have the description, the namespace, and the R folder. So these are the essentials, and then there's a few other things that kind of, because I've created it as an RStudio project, it's given me like a git ignore and a .rproj file, but we won't worry about those. So you can see that we have the description file open here on the left. The package name it took from my use this command. So if we remember, I just passed SnB example as the name of the package I wanted to create, and then it's left everything else for me to fill in. So I can give it a title. So I can just kind of simply type into this, fill it out, and save it. You can see it also allows me to track the version number. So obviously being a very new package, we can stick to kind of the general consensus for like the development version numbering, which is just to keep it as 0.0.9000. But as we do major, minor bug fix releases, we can obviously kind of increment this version number, and it's a good way to keep track of the changes in our package alongside something like a news file. You can see here we can also add some author information, so I can add my first and last name as well as my email and what my role was within the project. And then a description, and something that's obviously very important if we're wanting to share open source software is the license. You can see that it's already offered some kind of some licenses that we might want to use, but obviously, especially if it's something you develop within your company, then always worth checking with them, what the desired license is there. So our namespace at the moment we can take a look at, but it's just empty. The only thing that you'll notice is that it says it's generated by Roxvision 2, do not edit by hand. So we're not going to touch this ourselves. And then if we go into our R folder, again, we'll see it's empty. I haven't added any code, any functions to this package yet. If I did want to do that, again, I'm going to go back to the use this package. So if I look at all the functions within use this, there's tons of these use underscore something functions. So in this case, if I use underscore R, what it's going to do is it's going to add an R script for me called whatever I want it to. So in this case, I just want to add a script with some general functions in. So I'll just call it funcs for short. So if I run that, you can see it's opened up a funcs.r file for me. And if I look in my R folder, you can see that this funcs.r script is stored within there. So really quickly, just as a kind of very basic example, let's create a function called addition, which just takes A and B and adds them together. So so I can either run this, or what I can do is while I'm in this environment, I can load my package. So alongside use this, there's another package called DevTools, which is really useful. Offers you lots of, I guess, developer tools to kind of help you while you're building your package. And something that you kind of want to do probably quite often as you're testing is you want to kind of load all of the code that you've written so you can test it out. So now from my R console, I can use this addition function. So let's say I want to do the addition of 3 and 4. It will return 7 for me. Another neat thing that we can do here is we can add documentation for this function. So I mentioned that we do this inside our R scripts rather than having to write out documentation by hand. So what you can do here is you can go to your code in the top, and if you go to insert oxygen skeleton, it's a really good way to get kind of a framework for adding your documentation. So you can see here that it's added these kind of slightly different comments above my function. These are called just like the oxygen comments, and it's left me kind of a blank space to add a title, define my parameters. I can tell it what the function is going to return, whether to export it or not, and add some examples. So just as a quick example, I'm just going to fill this in slightly. So it's just a function that's going to add two values. My A and B are both going to be numeric. And let's say, as an example, let's just do the example that I did in the console. So if I save this file, what I can then do is I can do DevTools document. And it wants me to add a value for return, but I think that should have been enough to add yes. So you can see here that if I do question mark of that function now, it loads kind of the standard R documentation that you expect to see for any function, with my description, my kind of slightly poor definitions of my arguments, but hopefully you get an idea of how you could expand this so that your functions are easier for other people to use. The last thing that I'll show quickly is adding tests. So again, there's a use this helper for this. We can do use_test. So generally with like test files and R files, we kind of want the names to match up so that we can kind of clearly see which function we're testing in which script. So I'll call this funcs as well. And this does a few things for me. So the first thing it did, if we go to my root project directory, is it's added this tests folder. And in here we have this test.dat folder, which contains a test-funcs.r file, which is the one that's open. It's giving me an example little test. So what we're going to do is we're going to edit this just to test our addition function. So instead of doing this expect equal, I'm just going to, so test.dat offers like all of these expects functions. So there'll be kind of expect equal. You can do more kind of complicated expectations. You can do error checking. We cover kind of a lot more ground in the short course in October, but expect equal is just going to check that its two arguments compute to the same thing. So here, if I do addition of 2 and 2, then that should equal 4. So if I run this test after librarying test that, if I run this test, it will tell me that the test has passed, that those two things were equal as we wanted them to be. So yeah, hopefully you can kind of see how, as you get more functions, as you make changes. I think we had a good question in the chat as well about when to think about adding tests. I think a good general rule of thumb is as you add new functions or as you fix a bug within a function, adding a test to cover that functionality, and then this can be part of checks and all kinds of kind of continuous integration. Yeah, so I think I hope it's given you a very quick look at an R package and the structure and kind of how you sort of can build it up as you develop it. And I've also stolen a lot of Daniel's time to talk about the next section. So I'll pass it back to you.
Great. No, that was a great small intro. Yeah, and of course in the course then you will have time to build your own package and so on, and we will walk around and help you. So another topic we will dive in much more detail in the short course is a little bit on the workflow, right? There was a great question in the chat about a specific package to actually do this, but I will show you a little bit the bare bones way how to do this. So because what I always do is to start any functionality or any package with a so-called design doc. Okay, design doc, that's a language from Google. But basically, it means a single document that defines what is the purpose of the package, so or the functionality. So what are the objectives? What's the user interface? So you have basically the concept, and what are the main functions? So including the names, including some prototype code as well, that can actually be run, because that will help you to really align with your team and stakeholders if that's what they want, if that's what they need. And also to show yourself that everything kind of works together and you can actually run it and actually does the right thing. And only once you have that, then I would start with the actual package implementation. And there I would not put everything together in one pull request, but I would really just do one pull request for one function and always include the documentation tests for each function right away, right? So I would recommend not make the mistake to put all the functions in and then kind of later on kind of think about, oh yeah, now I add some documentation and now I add some tests. This usually doesn't go well. So a little example how this can look like from the RBMI package. So this is all open source here. You can later have a look at that. Here we had a design doc to align on specific MCMC option enhancements to the package. And this was already merged, but we can still look here a little bit how this looks like. So we basically had here a wish list. We had some more discussion here. You see, this is not even any code yet. It's just some thoughts and some ideas and some considerations as well. And only further down we have the prototype section. So here we have actually our function code, and then some other functions and so on. So this really then allowed to make the team have an idea of what I'm proposing, and then Craig, in this case, he reviewed this and he gave further input as part of the pull request, and essentially in the end then it was approved and this was merged. So this was kind of the first plan, and then later there was another pull request that actually then implemented this functionality and alongside the documentation and so on, right? And then there you can also see and what changed. It was of course the R function definitions, but also the tests, of course, that goes alongside with this. There was even also vignettes that were updated because things had to be documented also in the vignettes. So that kind of all goes together then. So this is just a little bit idea on the workflow. We will say more about this in the course, of course. Then a little bit to complement what Jack already showed regarding the tests. So, and also what I said before, so about the style. So basically high quality of your package comes mostly from a few things, right? It comes from the style. So that should be consistent also regarding the format. Recently, there's a very nice new tool, which is called Air, which is highly recommended to automatically format files as you save them very, very quickly. There's also another companion package, Linter, which is around for a long time already, that basically checks your style and gives you kind of error messages when things go wrong. And then as we have seen from Jack, tests are the other big component of quality, right? Tested is one very, very popular package to implement those. And then, of course, in addition, I would say also documentation, especially vignettes, are very important for the quality of your package. Basically to allow the user to understand what's going on in the package without having to debug all of the functions in your package, right? That's important for new users who are just starting with your package. That's also important maybe for let's say more expert users who really want to understand, for example, the methodological details in your package. So you should have, for example, some vignettes that explain the algorithm of your package, right? So let's say you fit some specific model. How does this model fit exactly work? What are the mathematical details of that, right? Those kind of things are very important. And also, actually, it's also going to be very important for you in the long term to have those vignettes, because those packages live much longer than you think in many cases. So So don't think this is all trivial. You will remember. You will probably not remember after a few years and coming back to the package. So it's going to be very helpful for you to then look at those vignettes and like remind yourself, ah, yeah, that's how we did it, right? High level idea. And then you can go into the code and into the details much more easily afterwards, right? We also put together from the OpenStats side this OpenStats guide. So this is a minimum viable good practices list for high quality statistical software packages. And we keep it here deliberately open. This is not just for R. So we even have a nice little mnemonic bridge sentence here. So basically it's about documentation, vignettes, tests, function, style, and lifecycle. And the sentences developers value tests for software longevity. So these, we have the D here for documentation, the V for vignettes, and so on. And then we have those recommendations. And you see when you scroll through the page, it's very short, okay? And we have recommendations on documentation. We have recommendations on vignettes, on tests, on functions, on style, and on the life cycle. So life cycle is about managing your package. So for example, reducing dependencies, and tracking dependencies, and those kind of things, change log, and so on, right? And then we always have examples here, both for R, for Python, and for Julia, what kind of tools are available to follow those, to implement those suggestions. Okay, over to you, Jack.
Okay, and thanks for the questions as well. Good to keep them coming in. I think there was one on thoughts on positron, but I haven't actually used it, so I don't know if Daniel, you're in a better position to answer that. I'm generally RStudio through and through. Okay. Yeah, so I hope this has helped, but the final step is obviously kind of making this package more widely available. So how can we publish it? So I talked earlier about kind of we can build it into a tarball and email it or submit it to CRAN. To be honest, that's kind of the hard way to do things, or the not the best practice way to do it. So a really good idea is to start with a GitHub repository. So as Daniel was saying, or showing, it's a really good way to collaborate with other users to kind of track your changes and make sure that your package is under source control. But it also means that people can directly install your package from GitHub to their RStudio session. It also allows you to add a package down website. So again, there's just a use this helper for that if you want to look into it, but it can give you a website a bit like this. So there's essentially kind of a bit of a README, so an introduction at the start, which you can set up. Then it will give you a reference tab with links to the documentation for every single one of the functions that you define within your package. So this is MMRM, so the package for mixed model repeated measures. You can also have articles, so you can see here that this package has a lot of articles or vignettes that that the users can read to get a better understanding of how to implement different methodologies by using the package. There's also things like the change log. So as we mentioned, as we're updating the version, it's good to have some kind of record of what's changed with each version, so that users can come back and if their code stops working, they can read the change log and understand if there's some breaking changes that have been introduced, for example. So a package on website is a really good idea to just help users to understand what your package is used for, how it's changing. There's also some quality checks. So DevTools check, for instance, will basically carry out like general quality checks of your package. It will run the tests and make sure they all pass. It will update the documentation. It will check that your description file is kind of conforming to good standards. And then the RHub check is a slightly more stringent one that's more in line with like the CRAN submission check. So always a good idea to run that if you ever look at submitting a package to CRAN. But like you say, once that's passed and you're ready, you can submit it to CRAN. There's a few more policies and things there to be aware of, but the CRAN team generally are happy to help with any issues you've got, and will kind of communicate to you anywhere where you might need to make some changes to to get your package onto CRAN. And then one last thing to mention is that you can, if you have a suite of packages, so if you're familiar with maybe the Tidyverse or the Farmerverse, they're kind of collections of packages that are all focused on a similar area, then you can set up your own RUniverse, which is essentially kind of a collection of packages with a similar theme. Okay, so again, this has been kind of a fairly brief introduction to R packages, to good software engineering practices within R. So hopefully you get an idea that we can dive into this a bit more in the course. We'll go through a few more examples. There'll be some exercises. We'll go into some of these topics a bit more in depth. But the idea here is that we can go from these unstructured scripts, which maybe kind of have various problems within them, which make the results hard to reproduce. They're tough to share with other people. There's no kind of testing. The styling means that it's not very readable, and generally just kind of tough to maintain, whether it's yourself, whether it's you might come back to your code in 6 months and find that you're struggling to remember exactly what did what, or whether you're sharing it with other people and trying to get them to help you as well. We want you to be able to go from that kind of situation to one where your code is much better organized. Even if it's just in a script, it doesn't have to necessarily be an R package, but it's good to know, how and when they're useful. We want to introduce you to these reproducible workflows and ways to test your package to ensure that the quality checks are being met. And all this can result in packages which are easier to maintain, R scripts which are easier to maintain and share with other people and have them understand. So I hope this was helpful, and I think Daniel, if you want to take us through the last few slides.
So as Sandrine already shared the link also to the course registration, this is another nice slide here to show where it will be here in Paris on the 10th of October. That's the Friday of the conference. So really looking forward to that, and of course also very much worth attending, of course, the whole conference, which is from Wednesday to Friday. There's also very nice list of invited speakers, so please have a look at the list. Some very good other speakers here are available at the conference. And there's also a lot of contributed talks and posters. So we also link to the program, which it looks very nice. Here's also another way to register for the conference with the QR code. I think the cost is also very moderate. The cost, by the way, the fee doesn't go to us, but it goes to the organizer and to the renting the room and so on. Yeah, you can answer the question if you plan to attend the conference. Exactly. Great. And there is another interesting thing here. There's also a second short course, as mentioned already in the beginning. So the second short course is about applied modeling in drug development, flexible regression modeling in STAN via BRMS. This is by Sebastian Weber and Lukas Wittmer, so I know both of them well, and this is also very highly recommended short course. This is on the Wednesday, and you can actually get a discount if you book both short courses. So you get 2 short courses for €250, so which is very good price, I would say. Yeah, and register early. Limited number of places are only available. And with that, I'm aware that we ran over the time, but are there any questions left? I'm also putting again the link in the chat. Is linked. It goes directly here to the previous slides that we shared today. Yeah, the conference is going to be on site. The short course is going to be on site only. That's kind of where we have seen in the past. So we have run this course almost 10 times so far in different locations across the globe. We almost always do this live in person, because that's where you have the best learning opportunity. And Jack and I will walk around in the room and then help people to get the things done and answer questions. So that's kind of the idea of the course. Yeah. Okay. Any more questions or comments?
There was, I mean, maybe one from the questions that I haven't answered around ensuring the stability of packages if, you know, from the packages you're depending on.
Oh yeah, how did you other packages different updated versions? Yeah, so part of the OpenStats guide is as well that sometimes it's worth to fix the versions of the packages you depend on using RN log files. So that might be helpful if you work with many other people together on a package and you run into those problems. Personally, I think this is not such a big problem in practice. I very rarely fix those versions with RN, especially when you work together in open source projects. It's very rare to do that. So usually this is not a huge problem. So I would not worry too much about this. Of course, if you see the problems coming, if you see it happening, then maybe it's worth to use RN log files. But otherwise, I wouldn't do this maybe from the very beginning personally. There's another question. I'm struggling a little to host packaged on website through CI/CD pipeline from Azure DevOps. Do you have any suggested tutorial readings on how it works on non-GitHub platforms? Yeah, I have only hosted it on GitHub pages. I don't know if Jack has any experience.
No, I don't, I'm afraid. I know the package down can be a little bit finicky at times. So yeah, I'm afraid I don't have an exact answer, but someone out there has probably encountered a similar problem.
Yeah. Okay, great. That's some very interesting questions. Very good. Okay. Yeah, great. And for those who are still considering to join a conference, yeah, definitely encourage you to come. I heard Paris is very nice in October and not so hot anymore, maybe like now, and not too cold, and a lot of nice autumn foliage around. So hope to see you there, and wishing you a great day ahead, afternoon ahead still. Thanks, Jack, and thanks to the organizers, Hanna and Caroline and Sandrine.
Yeah, thanks everyone. Thank you for your time.
Thanks all. Bye-bye.